The first question says 2 point charges are 3 millimeter apart and their combined charge is 8 microcoulomb. The force of repulsion between them is 0.012 Newton. What are the two charges? Okay, so very simple, we have to use here Coulomb's law. Let's assume that the first charge is Q1 and the second charge is Q2. But since their combined charge are in microcoulombs, so you should be very careful that the charge Q1 must be in microcoulombs. Let me repeat again. Your first charge should be in microcoulombs because the combined charge is in microcoulombs. So Q1 into 10 to the power minus 6 coulomb, I am assuming, and Q2 into 10 to the power minus 6 coulombs. Sir, what if we don't write 10 to the power minus 6 here? Then you will have problems. Then the outcome will be wrong. Okay, and you will get confused with the extra powers which will be arising, right? So Q1 into 10 to the power minus 6 and Q2 into 10 to the power minus 6. Okay, now their combined charge, which means Q1 plus Q2, okay, and whole multiplied with 10 to the power minus 6, that will be equals to 8 microcoulombs, which is 10 to the power minus 6 here. Now this cancels with this here and we got our first equation, Q1 plus Q2 is equals to 8. That's your equation number 1. Next, the force of repulsion between them is 0.012 Newton. Now force, which force acts between two charges? Coulomb's force. Okay, and what's the Coulomb's force from first chapter? F is equals to K Q1 Q2 upon R square. What's K? K is 9 into 10 to the power 9. So let's put here the values. So force F will be 0.012 and that is equals to K, which is 9 into 10 to the power 9. Okay, and what's the charge? The charge will be equal to Q1, and let's put Q2. Let's use substitution method. Q2 will be what? It will be 8 minus Q1. Correct? Let me repeat, Q1 and 8 minus Q1. Now listen very carefully here, very important thing. Okay, what is the important thing here? We have to put Q1 is in microcoulombs and Q2 also is in microcoulombs, so it will be 10 to the power minus 12. Let me repeat again. This is Q1 is in microcoulombs, so Q1 into 10 to the power minus 6, and again Q2 is 8 minus Q1 from equation 1 into 10 to the power minus 6, that becomes 10 to the power minus 12. Anyone has any doubt, they can speak. And what's the separation? Separation is 3 meters. So R square will be 9. I hope this is clear. Now let's proceed. Let's simplify. So 9 cancels with 9 and you left with here, this equation implies 0.012, that will be equals to Q1 into 8 minus Q1 and 10 to the power how much? Minus 3. Now if I take this 10 to the power minus 3 that side, it will become plus 10 to the power 3, which is 1000, and that will give you 12. Now 12 equals to Q1 into 8 minus Q2. Okay, now we have to use, okay, our quadratic formula. You can use quadratic formula to simplify this. Okay, but you can directly also solve it. Okay, look at this. So you can simply solve it as look, you can use the values, put the values here. So Q1 is 4 and put here, if I take first value, it will be 4 into 8 minus 4. So this will be 16. That's not possible. So first option is not correct. Let's substitute, or you can use using quadratic. Okay, so that's 8 minus Q1. Yeah, that's 8 minus Q1. Sorry, my mistake. Okay, now if you use the second one as Q1 as 6, okay, so check the second one is correct or not. So yes, if I put Q1 as 6 into 8 minus 6, that will be, now this is an effective or faster way of solving, okay, which we need for competitive exams, right? Otherwise you can also multiply this Q1 with 8 and Q1 with Q1, that will become Q1 square and you can simplify it. Okay, quadratic equation. So that's another way. I hope this is clear. So let's start with our second one. So question